Now, if you look at the example beside and what they've done for an example on the example beside, they've used the old technique of make a table of values. And if you're ever stuck graphing and you don't know what to do, this is the oldest strategy and one of the best strategies just to get a sense for what the graph is, what's happening in a graph. There have been some final exam questions where a lot of students get stumped, and those that go back to the basic strategy of making a table of values have figured it out where others haven't. Now, a table of values strategy, so if you're stuck, is just picking values of x and y and seeing what happens. Usually you choose values that are easy to calculate. So plug in 0, you get 0. Plug in 1, I would get 1 minus 3, negative 2. Plug in negative 1, I get negative 4. Now, the problem with just using a table of values is often you need to do quite a few of them before you really get a sense of what's happening. Okay? So, for example, on this one, what have we found so far? Well, we found 0, 0. We found 1, negative 2. And we found, oops. Oh, that's bad. 1, negative 2, and we found negative 1, negative 4. But that really doesn't tell us enough information about what's going on. So you would do more table of values to get that idea stronger. The other thing we're going to use is the fact that this is an x cubed, which is an odd function, so that we know that it acts like a line. So it's going to start down here in the bottom left corner and end in the top right corner as far as that graph goes. So that gives us a little bit more information about our graph. One of the things that we're going to use going forward, and you'll see it more in the second example, is we're going to see if we can factor things. Because if we can factor things, we're going to be able to solve them better. So in this one, sure enough, there's a common factor of x squared. And once you factor it, it's going to tell you your x-intercepts. Well, we already found out here that x equals 0 is one x-intercept. But now that we've factored it, we can also tell that x equals 3 will be another x-intercept. So now we've got 4 points, and we know what it's supposed to do at the end. So it's going to start down here. You don't know this yet, but it's going to bounce off this one, go through that point because we found that, and end up over there. That's the basic idea. And the fact that we see that it's an x cubed graph tells us that it's going like a line. Its end behavior acts like a line. And our table of values gave us some more points. Factoring it gave us another x-intercept. And we're going to find out by the end of class how I knew it bounced off of that one x-intercept. We're not concerned about how far the graph dips down. We're not concerned about where this local minimum is. That you're going to have to save for calculus for next year. You can do, yeah, if you wanted to have it dip down like really, really far, you could. Generally, that takes longer, so they just sort of make it go back through fairly shortly thereafter. So for as far as the sketch, they're looking for the end behavior. Later, they're going to look for your x-intercepts. We'll see in our example 2. And y-intercepts, but this one, the y-intercept was the same as an x-intercept. And then the basic shape needs to be a smooth curve going through those points. Okay? You would lose marks for drawing straight lines, because polynomials are nice curvy lines. So that is what I mean by the basic shape. Questions you can do, and we're not going to do B, because B does not factor nicely, and it would just be a big table of values. The only thing I would like you to notice in B is that because it's an x to the 4 and it's negative, it's going to act something like this. And you can type it into your calculator and see the graph. Let me just put up the questions for this one. 5. 6 and 8. And yes.